Hello class, today we're going to look at a lesson on sector area and arc length. Our objectives are we can find the area of sectors and we can find arc lengths. Some vocabulary for today. We have a sector of a circle, which is just a region bounded by two radii, which is the plural form of radius. So it's a region bounded by two radii of the circle and their intercepted arc. So we have a circle, we have two radii defining an area, and the area the formula to find the area of that sector is area equals pi times the radius squared times the angle's measure over 360 degrees. So let's look at our first example. Finding the area of a sector. We need to find the area of the sector, and we need to give our answer in terms of pi and rounded to the nearest hundredth. So our sector is sector MPN, where we have a radius of 3 inches, and we have an angle measure of 80 degrees. So let's start by writing out the area formula. The area formula is A is equal to pi times the radius squared times our angle measure in degrees divided by 360 degrees, because a circle is made up of 360 degrees. Alright, so we know the radius and we know the value for m, so let's plug those in for r and m. Our area will be pi times 3 raised to the second power times 80 over 360. So now we can simplify this. We can simplify 80 over 360. And we can simplify 3 to the second power. 3 to the second power is just 3 times 3, which is 9. So we've got pi times 9. And 80 over 360 simplifies to 2 over 9. So now we can multiply 9, which is really 9 over 1, by 2 over 9. And we know that this 9 and this 9 can cancel each other out. So we have our area in terms of pi, which is just 2 times pi inches squared. Now we also had to round it to the nearest hundredth. So we're going to go 2 times 3.14. And 2 times 3.14 is about 6.28 inches squared. So we've got our area both in terms of pi and to the nearest hundredth using 3.14 for pi. Let's look at one more example. Alright, so we have to find the area of the sector EFG in terms of pi and to the nearest hundredth. We have a radius of 6 centimeters and an angle of 120 degrees. So let's start by writing out the area formula. Remember, the area is equal to pi times the radius squared times the angle we're given in degrees divided by 360 degrees. Alright, so we know R is 6 centimeters and M is 120 degrees. So let's substitute those two values into our formula. A is going to equal pi times 6 to the power of 2 times 120 over 360. So we know that 6 to the power of 2 is 36, so we have pi times 36. And we can simplify 120 over 360 right away. And 120 over 360 will simplify to 1/3. Now we can multiply 36, or 36 over 1, by 1/3, and we know that 36 and 3 will both reduce. 3 will reduce to 1, 36 will reduce to 12. So in terms of pi, our area is 12 pi centimeters squared. And now we want to find what that will be rounded to the nearest hundredth. So we're going to have to write it as 12 times 3.14, and 12 times 3.14 is about 37.70 centimeters squared. So we've got our area both in terms of pi and rounded to the nearest hundredth. We can move on to our next example. So we have an agriculture application. We have a circular pot with 720 feet diameter, is watered by a spray irrigation system. To the nearest square foot, we need to find the area that is watered as the sprinkler rotates through an angle of 50 degrees. So we need to first understand that we need to use our area formula. A equals pi r squared times the angle we're given divided by 360 degrees. So we know that the diameter is 720 degrees, or 720 feet. We learned the other day that the diameter is just 2 times the radius. So to find the radius, we just have to divide 720 by 2. 720 divided by 2 is 360. So we know r. We also know the measure of angle m. They told us that this sprinkler rotates through an angle of 50 degrees. So m is 50 degrees. So we know everything we need to know to plug into our formula to find out what that area will be. So our area is going to be equal to pi times 360 raised to the second power times 50 over 360. Okay, so let's do our exponent. You can plug 360 into the second power into your calculators. That's going to give us pi times 129,600 and 50 over 360 we can simplify to 5 over 36. So now let's multiply 129,600 by 5 and divide that by 36. So we're going to have 18,000 pi. But because this is a real-life application, let's actually multiply 18,000 by 3.14 to get 56,520 feet squared. So our final answer is 56,520 feet squared. All right, let's move on. So our next vocabulary alert, we're looking at arc length. Arc length is simply the distance along an arc measured in linear units. So we have a formula for that. If we're given a circle and 2 points on the circle, when we move around the circle from one point to the next, that is our arc length. Our formula to find the arc length is just the arc length, or L, is equal to 2 times pi times the radius times the angle of the arc divided by 360 degrees. So let's look at an example. All right, we're going to find each arc length and give our answers in terms of pi and rounded to the nearest hundredth. So we have a circle to the right that has a radius of 10 feet and an angle of its arc of 90 degrees. So we know that the arc length formula is L is equal to 2 times pi times the radius times the measure of the angle over 360 degrees. We know M and we know R. R is 10 feet, and M is 90 degrees. So we're going to plug those values into the formula. We have 2 times pi times 10 times 90 over 360. Now we can go 2 times 10 and get 20, so we've got pi times 20, and then 90 over 360 we can simplify to 1 over 4. Now if we multiply 1 over 4 by 20, that gives us 5. So in terms of pi, the arc length is 5 pi feet. Now we also want to round that to the nearest hundredth. So we need to take 5 and multiply it by 3.14, which is going to be about 15.70 feet. So we've got our area, or our arc length, in terms of pi, and rounded to the nearest hundredth. Let's do one more example. So we have a circle with an arc measure of 35 degrees and a radius of 3 inches. So we know that the R that we'll need to use in our formula is 3, and the M is 35. So let's start by writing out the formula again. L is equal to 2 pi, 2 times pi, times R, times M, over 360. Let's plug in R and 35. So we have 2 times pi times 3 times 35 over 360. Now we can simplify. 2 times 3 will give us pi times 6. And 35 over 360 will give us 7 over 72. So, now we can do some more simplifying. 6 goes into 72 12 times, so we can cross 6 out, and 72, 6 turns into a 1, 72 turns into 12. So we have pi times 7 over 12, which means in terms of pi, the arc length is 7 over 12 times pi inches. Now we want to find out what that would be to the nearest hundredth. So we have to go 7 over 12 times 3.14, and that is going to be about 1.83 inches. So that wraps up our lesson on sector area and arc length. For your homework tonight, I would like you to do the your turn problems in your guided note sheets, and I will see you in class tomorrow. Have a good evening.